we talked about the different ways things can be inherited. When we're talking about two traits that are on chromosomes 1 through 22. Remember how many pairs do humans have? 23 pairs, right? So everything that we looked at yesterday, and everything we've looked at so far, have been when the gene is on chromosomes 1 through 22. And when they're on chromosomes 1 through 22, everybody gets 2 copies of it, every human. And that's why we end up with genotypes that look like this. They have 2 letters. They didn't sign it. So they have 2 letters. Capital because one's dominant, lowercase because the other's recessive, but 2 copies because they occur on chromosomes 1 through 22, the autosomes. The ones that don't have anything to do with gender. And if you remember looking at our karyotypes, 1 through 22 were all different sizes, like 1 was a different size than chromosome number 2. But when you lined chromosome number 1 up next to its partner chromosome, the other chromosome number 1, they were exactly the same size, right? And they were homologous. They contained exactly the same genes. So your number 1 from your mom contains height, hair color, eye color. And number 1 from dad contains height, hair color, eye color. There is one change at chromosome pair number 23. What do we call those? Yep. Those are the ones that determine the sex of the individual. So we call them sex chromosomes. And we have 2 choices. Girls get what? So a girl are 2 X chromosomes. And a boy is an XY. Now here's the problem. There are genes located on the X chromosome that are really They determine whether or not you have certain diseases. They determine whether or not you're able to see color. And those occur on X. Girls get 2 copies because they have 2 X's, right? An X from mom and an X from dad. Boys only get 1 copy of the X. That means that whatever mom gave them for that particular trait is going to be what you see when you look at them. So, what we do when we say that, when we talk about genes that are located on the X, we write them like this. That's what happens when it's a dominant gene located on the X chromosome. That's what we write if it's the recessive gene. It's the lowercase. Just like we would up here, uppercase is dominant, lowercase is recessive. But here we're saying this is dominant and it's located on the X chromosome. Or this is recessive and it's located on the X chromosome. There are, before we even look at diseases on the X and Y chromosome, there are people who like to predict whether or not someone who's pregnant has a boy or a girl, right? How many of you are already or have already asked Mrs. Cheek what she's having.
My mom knows that before. Who's cheap? I had
She's rocking a baby bump.
I
Fairly.
haven't even seen her.
Well, next time you see her,
I
you'll see
noticed
it.
it last week.
Yeah, she's rocking a baby bump.
I'm guessing it will be a boy.
Well,
Yeah, me too. I say girl.
we've got two choices, right? It's gonna be a boy or it's gonna be a girl.
You never know.
And there are some people who like to believe that by looking at someone, you can tell what they're going to have.
Really?
Can you really tell? No. Are there people who think you can? Yes. There's all kinds of old wives' tales about the shape of the baby bump and whether or not it's a boy or a girl.
Dirty. Stomach fruit.
There is only one way to determine whether it's a boy or a girl.
All just
Indeed, here's how we do it. Some people believe they can control whether or not they're going to have a boy or a girl based on what they eat or how much exercise they do or any of that. What two sex chromosomes will the mother bring to the party every time?
X.
She's never going to change what she gives her child. She is only responsible for an X chromosome. The father is always XY. So if we're to do a genotype-phenotype ratio between boy and girl, your odds are always
50-50.
50-50. No matter what you do, no matter what you eat, no matter how much you exercise, no matter what the shape of the baby bump is, your odds are always 50-50. That's the pattern of inheritance. So for any of you who had fathers like mine, who were fairly bummed out he wanted boys, he was going to have Matthew, Mark, Luke, and John. He got Susan, Sarah, and Elizabeth.
0 boys.
0 boys.
Yeah,
It's a shame. Well, not
And,
a shame, but
Whose fault was that? His.
his
There's
fault.
nothing my mom could have done about it, right? All she brought to the party was X's. The male determines the gender of the child.
Good job,
So father
Dad.
determines gender. Genotype ratio is always 2 of 4 or 1/2. Doesn't matter birth order. This is not saying girl 1 will be, or child 1 will be a girl, child 2 will be a girl, child 3 will be a boy, child 4 will be a boy. Every time you draw a new Punnett square for that child. So every pregnancy gets a new Punnett square, every time it's 50-50. Some families, yes, there will be 8 kids. 7 of them will be boys and 1 will be a girl. It's just probabilities. All that is.
That would be sense to be the one girl.
That, there's not much point in me having you practice Punnett squares that way, because that's a given. That's as it will always be. What's more interesting is to consider diseases that occur, or traits that occur, on those sex chromosomes. Sex-linked traits. There are a variety of them, such as colorblindness. So red-green colorblindness is in fact heritable. Occurs more often in males than in females. Red-green colorblindness is recessive, and it occurs on the X chromosome.
Can you play that down?
Just like we said yesterday, you have to choose your letter wisely for deciding what you're going to call the allele. I would not call the colorblindness allele C. When you make it a superscript, it will look exactly the same. So I would say your choices are X capital B for can perceive color, or X lowercase b for cannot perceive color. Whether or not you have a widow's peak, so your hairline determined by the X chromosome. So whether or not your hairline recedes farther back on the sides, or your hair goes straight across your forehead. You'll notice everybody in your family is probably similar. Wait, your dad, widow's peak or bald?
Well, he's almost bald. I don't know what a widow's peak really looks like. Let's Google it. Yeah, Google, can you?
Male pattern baldness. X chromosome thing. There's a reason why men are bald much more frequently than women.
Just shade.
Male pattern baldness.
That'd be disgusting.
Not really a problem for women. Not anything you really think, oh, I mean, yeah, when you get really old, like my grandma, 98, and, you know, doing her
Ooh.
thing. Yeah, her hair is
Sick.
thinning,
She's 98.
but she's not bald.
Oh my goodness. It's hard to write with this thing.
I know, bro.
Hemophilia.
Yes,
It is
sir.
a disease
Nothing like
that affects your blood's ability to
Oh, you're
carry
right.
oxygen. That disease is carried on the X chromosome. And it's a fairly serious disease. Again, affects males significantly more often than females. Females, unfortunately, end up being carriers for these traits or diseases rather than sufferers. So what I mean by carrier is, let's take a look at hemophilia, for example. For our female potential genotypes, a female can be X capital H. She's healthy, normal, and not a carrier. She can be X capital H, X lowercase h. She's healthy. Healthy is dominant. But she is a carrier and can pass it on to her offspring. Or, in very rare and infrequent instances, she has two recessive genes and has hemophilia. This is more rare because that requires that you have a mother who was either a carrier or suffered herself, and a father who had the disease. So anytime you have a female who's homozygous for a particular trait that's sex-linked, her dad had the trait. So it's just like colorblindness. It's rare to have a female who's colorblind because that means that two colorblind people likely had a child. Probability of having a spousal pair who's both colorblind, infrequent. Like, where are they going to be? How many of you can think of someone you know is colorblind? Support group for people who are colorblind? I mean, nobody here is one person?
My dad is.
Your dad's colorblind?
My dog is colorblind.
Do you have any colorblind siblings?
Not that I know. Can you be like colorblind to a certain color?
Can you be what?
Can you like be colorblind to like a certain color?
Yeah, absolutely. Red, green colorblindness, you can't distinguish red and green. But you can see the other
Can you
colors.
be like fully? Okay, that would make
All
it
you would
clear.
see is shades of gray.
All dog 50 colorblind.
Sorry, you done messed up. Ruined your car.
Dude, that would be terrible. No car.
Males,
Everything
two
would be
choices. Males, either you're healthy or you're sick, and there's nothing.